Good morning. I'm Dan Ogden from the Idaho National Laboratory. I'm the Deputy Director of the Nuclear Science User Facilities, and I'm going to talk about changes regarding NSUF and the FOA this year, and also our NSUF2 work scope. Specifically, we'll get into the detailed changes in the FOA, a little bit of discussion on our new partners in NSUF, and also talk a little bit about the NSUF2 work scope, which is essentially unchanged from last year's FOA. Changes in the FOA for 2017. One of the big changes for NSUF is an increased focus on applicant readiness for NSUF access. You could interpret the word focus as increased scrutiny. We've had a fairly recent history of applicants that received awards that were really not quite ready for NSUF access. So we're going to focus on that this year in the process. There'll be some details that need to be addressed. In the pre-application, a summary of readiness is required, and a more detailed description of readiness is required in the full application. And NSUF will review the readiness information in both the pre-application and the full application prior to invitation and award. So what we're looking to regarding readiness, things that should be complete prior to application. There's 3 bullets here that address these in general. The more information that can be provided, the better. We're looking for completion of development qualification of fabrication techniques, processes, and methods. Pre-characterization irradiation, whether that be physical, mechanical, thermal, chemical, and any other applicable properties that need to be understood prior to irradiation. Any mechanical interaction studies that need to be completed, those should be, of course, completed at the pressure, temperature, chemistry at which we would irradiate the materials, as well as corrosion studies. So these are all important preparatory activities that should be completed prior to applying for NSUF access for a neutron irradiation. Other things that should be addressed in the readiness in the narrative, these are things that will help us ensure that the applicant is really ready to move forward with an irradiation experiment. Structural and cladding materials, we need to have those about 3 months after project initiation. This is really fairly quick after award, so the applicants need to have a good plan to have the materials ready, which would include supplier commitments, lead times. The material will need to be machined into final configuration after we have gone through the design process. So we're not looking for final specimens in final configuration, but bulk materials available, and a plan to have those ready fairly quickly after award. For previously irradiated fuels and materials that are not in the NSUF Fuels and Materials Library, it's important that the applicant identify the location as specific as possible. So we're looking, ideally we would know facility, perhaps a specific area in a facility. So we don't want to know what state it's in. We want specific location. Any general information on the condition of the materials, provenance pedigree, radioactivity levels, isotopic content, material composition, configuration, ownership, any other available information that will be needed in order to ship or prepare the materials or fuel for examination. So that's a lot of very specific information, but it's important that it's known at the time of application so we really know if the material is appropriate for the proposed activity. Any fuels or materials supplied for the purpose of neutron irradiation, the applicant must own and have full authority to transfer ownership and title to DOE. So obviously if the material is already owned by DOE, that's not an issue, but if the material is owned by a third party, the applicant needs to have ownership and the authority to transfer that to DOE. That's part of our user agreement. Any fuels and materials coming from other DOE programs, a statement of program commitment is necessary. So if the material is controlled by one of the other NE programs, we just need to know that they'll release it for the NSUF project. Okay, another aspect of changes here for the FOA for 2017. NSUF, since being part of the CINR, has always had a statement of work that was part of our feasibility study. It's a very important piece of the feasibility study because it helps us determine, first of all, if the project can be completed, but also to determine the cost so that we know what the NSUF portion of the cost will be. Previously, this had been handled in a less formal process via email. We're now going to formalize this process and make it directly part of the FOA. So the statement of work, both preliminary and final, will be handled through the NEUP website, just like the pre-app and the full application. Preliminary statement of work is due on November 17th, and the final statement of work for full applications is due on January 22nd, 2018. There is a statement of work template provided in the FOA, and the NSUF technical leads will work with the applicants to get all the correct information in the statement of work. User agreement. The user agreement was discussed last year quite extensively. The acceptance of the user agreement has been moved from the letter of intent stage to the pre-application and full application. The purpose of this was to allow a little more time for the applicant's institution's legal department to review the user agreement, make sure it's acceptable. There's approximately 6 weeks from FOA release to pre-application. So this allows a little more time for the legal review. Our standard agreement is in the FOA in Appendix E, so you could certainly start looking at that now if you have any concerns with how quickly your legal department can review the document. And there is a special version of the user agreement that's available for Colorado public institutions. And the agreement is, of course, non-negotiable, as it was last year. A few reminders. These are things that are not necessarily new, but just reminders for everyone. Uninvited applications will not be reviewed for NSUF access. The Department of Energy reserves the right to decouple R&D requests from NSUF access and evaluate and fund either portion if feasible. So this would be applicable in the NEAMS 2 and the NSUF 1 work scopes where the applicant has requested R&D funds as well as NSUF access. High performance computing capability is available through NSUF. We're encouraging everyone to take advantage of that. Source scope and duration of R&D support must be identified for NSUF access only. That's the NSUF 2 work scope. We want to make sure that the applicant has R&D support through the duration of the project. Our NSUF process is described in Appendix D, way at the back of the FOA, but please thumb all the way to the back and look through that. Current LOI due date is August 31st, and pre-application due date is September 20th. Okay, I want to touch just quickly on 6 of our newest partner facilities that are just coming online for NSUF. I'm not going to go through all the details, but I just wanted to mention these. We haven't had a separate press release or other activities for the new partners coming on, so this is sort of the first unveiling. In Allison Hahn's presentation before mine, she also mentioned NSLS2 at Brookhaven and IVEM, which formalized agreements were established this year, but those were actually available last year, so I'm operating on the assumption here that this is the latest new information that folks are not aware of. So we brought on Lawrence Livermore National Laboratory, their Center for Accelerator Mass Spectrometry. These slides will be available for additional detail if you'd like to take a look at those. There are also information's coming up on the NSUF website related to these capabilities, so you can go there as well. Los Alamos National Laboratory is joining NSUF. It'll be some of their hot cells, the Lance and Lujan Neutron Scattering Center, also their Plutonium Surface Science Laboratory will be available through NSUF. The Ohio State University Research Reactor has joined NSUF. It's a 500 kilowatt pool type research reactor with some unique capabilities. Sandia National Laboratories has also joined NSUF with their ion beam laboratory and their technical area 5, which is primarily the annular core research reactor and the gamma irradiation facility. Texas A&M also joining NSUF, ion beam laboratory there with multiple ion beam type capabilities. And the University of Florida. The University of Florida brings on PIE capability. Details on what radioactivity limits can be handled will be available on our website, but they've got a hot fib and TEM that will be available. Okay, that covers the majority of the changes to NSUF. I just talk a little bit about the NSUF2 work scope, which is the NSUF access only. The objective of this work scope is to just provide access to NSUF, the types of projects that can be proposed, radiation only, radiation and PIE only, or a beamline project, restrictions related to this work scope. This work scope does not provide R&D funding, and NSUF does not fund travel, salaries, or other user costs. So you need to have your own R&D support if you're applying for this work scope. And you also need to tell us what the source scope and duration of that funding is so we know we have support through the project. As I mentioned earlier, the preliminary development effort should be nearly complete, and we're looking for a detailed explanation of that this year in the FOA. Okay, the focus areas related to the NSUF2 work scope. NSUF 2.1, core and structural materials. It's related to understanding material degradation mechanisms due to irradiation or irradiation combined with other environmental effects. Development of radiation-resistant materials for current and future reactor applications obviously be a key element of that work scope. NSUF 2.2, nuclear fuel behavior and advanced nuclear fuel development. This work scope is geared towards increasing fundamental understanding of the behavior of nuclear fuel, improving performance of current fuels, R&D related to advanced fuels, radiation thermal effects on microstructure, thermophysical and thermomechanical properties, chemical interactions. Projects in this work scope should aim at proposing simple irradiation experiments with PIE examination investigation of the fundamental fuel performance aspects as radiation damage, species diffusion, or fission products. NSUF 2.3, work scope for advanced in-reactor instrumentation. This is geared towards characterization of materials under irradiation in test reactors, but looking for instrumentation to measure dimensional changes, crack propagation, internal fission gas pressure, other instrumentation that's non-intrusive to the specimen. Applications could be related to online condition monitoring of power reactors. We are, of course, interested in non-traditional techniques, optical fibers, ultrasonics, wireless transmission. NSUF 2.4, these would be experiments with synchrotron radiation. In the past, these would have been done solely at MRCAT at APS, but now could also be done at NSLS2 at Brookhaven. Focus here is fundamental aspects of radiation damage, phase stability and phase transformation under radiation, surfaces and grain boundaries in irradiated materials, deformation and fracture of irradiated materials, and physics and chemistry of nuclear fuels. So that covers our 4 pieces of the NSUF2 work scope. For the NSUF2 work scope, our federal program manager is Allison Hahn, who presented right before me. Our technical lead is Rory Kennedy at the Idaho National Laboratory. Rory is, of course, the director of NSUF. And with that, we'll see if there's any questions.
We'll wait for the next few minutes to take any questions. Please submit those to the question box. While we're waiting, in the system, Dan just went over the 4 areas for the NSUF2. You will need to select a specific category, one of those 4 categories in the system this year rather than putting your application just in the NSUF2 category. So please be aware that you'll need to down select into one of those categories. Dan, can the rights of use be limited, or does DOE take full ownership of the materials/technologies?
DOE takes full ownership of the materials. The question on the rights of use is something we probably need to discuss in more detail related to the legalities of the user agreement. But DOE takes full possession of the materials, and obviously all the work that NSUF does is non-proprietary, so the results will be published. There could be some prior rights there that could be discussed. It's sort of a complicated question, perhaps to answer it on this forum. I don't think that's a question.
Are there any plans to add more facilities to NSUF in the future?
Certainly a possibility if other facilities apply to become NSUF partners. They'll be evaluated in light of what our current capabilities are to see if they offer a unique capability or a capability perhaps that's oversubscribed. So it's possible. We currently have 20 partners, so we have a pretty good set of capabilities at this time. So it would need to be something that was fairly unique.
Can we talk to a point of contact at DOE prior to submitting the concept for our application?
Certainly. You certainly talk with Allison Hahn as a good starting point, as she's the program manager for NSUF, and she could help guide that conversation to wherever it needs to go.
Does control materials fall under 2.1 or 2.2?
If they're core and structural materials, they'd be under 2.1. If they're fuel related, they'd be under 2.2. So, are we talking control rods or experimental control samples? I guess we don't know, but
well, the individual can put a clarification in, and we can get an answer to that question. How are the NSUF 1s reviewed?
The review process for all of the NSUF work scopes, whether it's NSUF 1 or NSUF 2, is the same. It's described in detail in the FOA. I don't think we want to try and go through all of that detail at this point in time. If there's clarification there, we could try and address that on the question.
Do proposers have to travel to these sites to use the NSUF facilities, or can they just send samples for examination?
That's a good question, and we certainly encourage the applicants to travel with the samples and be part of the process so that they can, if they're doing just a PIE only experiment, it's always best if the applicant or a representative is at the facility where the R&D is done, so they're there real time. They can look at the results, make any little adjustments that need to be done in the examination process. So that's our preference, is that the applicant does participate directly in the examination.
As a clarification to the controls material question, the reference is to accident tolerant control rod control materials.
That would be under 2.2. If they could tell us what the material is, we'll know for sure. So
on that question, it may be
is it a hafnium control rod, or if the best thing for this particular applicant might be to contact one of us, and we can have a more detailed discussion. We certainly can help guide the applicants into the right work scope. So we think that based on what we have, that probably fits in 2.1. But I would encourage that particular individual to contact us for a little more discussion.
If NSUF 1 research has overlap with programmatically funded research, is that advantageous to the success of the proposal? I'm not sure if they're asking if linking those two is advantageous.
That's a pretty difficult question to ask here without understanding the specifics. So it obviously needs to be focused on the correct work scope. The work scopes are tied back to the program, so we would expect there to be a relationship there. I don't know what the nature of the overlap might be. So.
Good morning. I'm Allison Hahn, Program Manager for Advanced Methods of Manufacturing. I'm going to be discussing two separate work scopes today. One is R&D only support. That's the NEAT 1 work scope. And then there's R&D and access. That is the NSUF 1.2 work scope. I'm going to be discussing both of those today. To clarify, NEAT 1, the R&D only, is open to universities and national labs. NSUF 1.2 is open to everyone, industry, universities, and national labs. I just want to make that clarification because there are a few changes this year. So I want to make sure everyone's on the same page. The AMM vision and goals. The AMM program has not changed dramatically since it was first created in 2012 under the Cross-Cutting Technology and Development Program. The vision of the program is to improve the methods by which nuclear equipment, components, and plants are manufactured, fabricated, and assembled, utilizing advanced manufacturing practices found within other industries. The goals: reduce the cost and schedule to build these new plants, making it less expensive, faster, while also being more reliable. So for the NEAT 1 focus areas, this is the R&D only portion of the work scope open to universities and national labs. We've called out 4 focus areas: factory and field fabrication techniques, advances in manufacturing processes, additive manufacturing techniques. We're looking for additive for advanced materials and multi-materials. We've funded a number of projects on stainless steels and Inconels and current materials. So we're looking to extend that process. And then development of in situ quality control techniques for high-speed manufacturing. Factory and field fabrication techniques. So we're looking welding technologies, weld monitoring technologies. We have currently an online weld monitoring control system using optical methods. We funded another monitoring program that has recently ended. So I encourage you to go on to the CTD website, energy.gov/NE. You can find the cross-cutting technology development link. We have an annual award summary on all of our projects. I highly recommend you go and look at those to see what's currently been funded, because we do have a couple of projects in this area, and we are not funding anything duplicative. So I encourage you to look at that. Surface modification techniques and shop floor site operations, improving those processes. Manufacturing processes for components. I want to emphasize that here. The AMM program looks at components. We do not manufacture fuel assemblies. Fuel support assemblies, but not fuel. I want to emphasize that here very highly. Again, surface modification, cladding for those, corrosion and wear-resistant applications, all of that is included in this one specific focus area. Additive manufacturing, I'd mentioned that we have previously funded a few AMM projects, laser powder bed, laser dep, e-beam welding. We also have one project on monitoring laser powder bed processes. I encourage you to look at the work that's been done, build upon that, include advanced materials, and multi-material is something that we're highly interested in this year. Again, stainless steel, Inconel, ODS, we have looked at those. Build upon that work, see the successes that they've been able to acquire and continue to move it forward. I apologize for the typo in this slide. It's NSUF 1.2, not C 1.2. This is R&D and access to the nuclear science user facilities. This is open to all universities, national lab, and industry. We're looking to further the manufacturing processes, something that you would need NSUF access, including neutron irradiation, ion irradiation, post-radiation examination. These projects are bigger than the other projects in the terms of access funding. It is $500,000 in R&D support and access to that. If you're looking for a neutron irradiation, up to 7 years, $4 million is what we're looking at typically for those large long-term irradiations. We also do post-irradiation examination. We have ion beam facilities. We do ask that these results be tied to using the high-performance computing and tying that information into the modeling and simulation programs that we have as well. The components for NSUF testing need to be developed. This is not the development portion of your work. That should be done previously. We ask that all materials and components be available to the NSUF program within 6 months after award, so it's a quick turnaround. You're not doing R&D on the process at this point. This is further testing from that. I just wanted to clarify that as well. So the summary, again, the AMM program increased the reliability while decreasing the cost. Pretty straightforward. Another thing that the AMM program likes to point out is that the projects that the AMM program supports, we are looking for that acceptance by the codes and standards and regulatory bodies. That's something that we are highly interested in getting that acceptance and getting that out into industry. So I want to stress that. And then, of course, being able to be deployed in the commercial nuclear reactors, the extent of our R&D. And with that, I will open up to any questions.
Okay, please submit your questions through the question application on the GoToWebinar.
Sorry.
Allison, are there specific components for which additive manufacturing methods are of interest?
There are no specific components that we're looking for, just not fuel. We've done fuel spacer grids, safe ends, nozzles. We've looked at a few different types of components, just not fuel.
If a material is under investigation currently with a certain advanced manufacturing technique, can the same material be the focus of a different AM technique?
Say that again?
If a currently funded project is investigating a material with a certain advanced manufacturing technique, can you do a different advanced manufacturing technique on the same material for your proposal?
Yes. We've done laser powder bed and laser dep on 316, so that's not unprecedented, not at the least, no.
Would you fund a project that advances construction processes, i.e. construction progress and quality control?
I would have to see the proposal and see that how it's set up. That's a tough call. We look at fabrication and manufacturing, but we have considered construction processes in the past.
What are the expensive components to fabricate currently?
large components, single-use components that aren't readily fabricated. I have a specific example off the top of my head. I can certainly get back to you though if you're interested in that. Just email me.
Okay, the draft FOA says NSUF 1.2 is lab and university-led only. Can industry lead?
Yes, we are making that correction. Industry can lead NSUF 1.2.
Is concrete shielding considered under advanced manufacturing?
We have funded a number of concrete projects. So the concrete material, yes, that is included in AMM.
Will you fund NDE for building components of nuclear power plants?
Will we fund NDE of building components?
For building components.
I would need to see the proposal again. We've funded NDE in the past. It's been encouraged. So off the top of my head, I would say yes, but I'd need to see the proposal.
Is there an interest in identifying all the variables / parameters in the AM process and optimizing them
Yes.
to arrive at the required physical and mechanical properties?
Yes, we know this is a issue with AM. I'm highly interested in that.
What types of non-destructive measurements on additive manufactured components are of interest?
I would have to get back to you on that question. I know that they've looked at UT, other methods. I'd have to get back to you on that actually though, on specific.
Do you consider advanced joining or welding techniques as innovative manufacturing techniques under the NSUF 1.2 work scope?
Yes.
Allison, could you please repeat the website for the cross-cutting technologies summaries that you were talking about?
The website, the URL is lengthy. If you go to energy.gov/NE, there's a little link at the top that says initiatives for NE. There's Nuclear Energy Enabling Technologies. Click that link and you'll see the most recent publications. AMM's annual award summary is listed on that page. If you'd like to email me, I can send you the direct URL. It's just pretty lengthy to say right now.
Are studies that characterize the material and mechanical properties of components made with additive manufacturing of interest?
Repeat that again?
Are studies that characterize the material and mechanical properties of components made with additive manufacturing techniques?
This is where we need to be a little clear. This is a manufacturing program. There are materials programs that research specific materials. We are looking at manufacturing processes to increase the schedule, decrease cost, increase reliability. There are mechanical testings that need to be done with new additive advanced manufacturing techniques in general, but material properties that might go into more of the materials R&D work scope areas. That's something that we do need to be a little careful about.
These last two questions I can answer. The question here is, how do I get a copy of the slides? All of these slides will be made available on NEUP.gov after the webinar has finished tomorrow. And the other is a question about whether or not you can contact a program manager or technical lead to talk about your concept, your idea. The answer is yes. Up until the full application stage, you can talk with a program manager or technical lead about your project. Allison, is additive manufacturing of steam turbine within the scope of NEAT 1?
Yes. It's within the nuclear plant, yes.